So these are just different quote unquote, forms of DNA in terms of how they spin, in terms of their double helix. So discovering DNA structure. Hint. So we're going to go over these in a little bit of detail. Please pay attention. So Chargaff. Basically, these are just things that you should be aware of in terms of DNA. So Chargaff's rule. The total number of purines is equal to the number of pyrimidines. The total number of purines is equal to the number of pyrimidines. Chargaff's rule. Wilkins and Franklin. So Rosalind Franklin, all that type of stuff. Photographs, they use X-ray diffraction to see the structure of molecules. They directed a beam of X-rays and analyzed the pattern on a piece of film. The photographs indicated that the DNA molecule resembled a tightly coiled helix and was composed of 2 to 3 chains of nucleotides. So this is back in 1952, guys. That's kind of crazy, not gonna lie. So this is Franklin, and this is the image that they produced. And from here, they somehow, I'll say that, somehow envisioned the double helix structure. Just saying. I know. I know what you're thinking, and yeah, I know. Watson and Crick. So these guys, they kind of use other scientists' work, and this is a nice way of describing it. They use other scientists' work, and they built a model of DNA with a double helix twisting around a central axis. So this is the DNA model they created. Yeah, they use other people's work. I'll say that much. So this is what I was talking about earlier. Watson and Crick, this is where they kind of have the base pairing rules. On one end, you will have you'll have a purine, and on the other end, you will have a pyrimidine kind of based up or paired up with it. I'm sorry. So adenine and thymine again, 2 bonds, hydrogen bonds. Cytosine and guanine, 3 hydrogen bonds. The sequence of bases on one strand determines the sequence of bases on the other one. So DNA replication. So this is making a copy of. This is the last section. Okay. It occurs during S phase of mitosis. S phase of mitosis. S phase. S phase. S phase. S phase. If this is not a hint, I don't know what will be. Okay. So there are a set of steps, and this is please pay attention. That's all I gotta say. Step 1. Remember, it's a double helix, so it unwinds, and it's caused by something called DNA helicase. Remember, it's ACE at the end, so that means it's an enzyme. And where the double helix separates, they form something called replication forks. And I will tell you, you're getting like the abridged version of this. And when I was in medical school and in college, a lot of detail with this. I'm telling you guys. So if I were an enzyme, no, I'm not gonna repeat this out loud. You can read this yourself, okay? I'm not gonna repeat this. You can read it. It's fine. So step 2, at the replication fork where it separates the helix separates, there is a certain enzyme that moves along, and they start adding nucleotides. So this is DNA polymerase. They add nucleotides to the part that's being replicated. As the enzymes move along, it's supposed to be a star. As the enzymes move along, 2 new double helixes are formed. So this slide just shows you how replication forks can look in different types of DNA. First one's prokaryotic, so there's bacteria, I guess. Circular DNA. However, here's what we're more focused on. So, quick recap. Replication forks, here and here. What unwinds the DNA? That is DNA helicase. Oops, that was ugly. DNA helicase unwinds DNA. And the ones that add new DNA as nucleotides, that is DNA polymerase. So notice I'm being specific with these, so that means that there's probably going to be another type of polymerase and helicase later on. Step 3. All of the DNA is copied and the DNA polymerases are signaled to detach, and you end up with 2 DNA molecules at the end. And these are just this is just how to replicate DNA, if you will. So checking for errors. So DNA polymerases have a proofreading rule. That means that they can actually, hey, double check if all the nucleotides added are being paired up correctly. And what it can actually do is that it can remove the incorrect nucleotide and replace it with the correct one. So DNA replication, checking for errors. DNA polymerase is responsible for all of this. An entire human chromosome can be replicated in about 8 hours. That's actually kind of cool, not gonna lie. Anyway, so this is the last slide for chapter 9. So I'm telling you, you covered chapter 9 in like about, this is like 16 minutes total. So if you have any questions, let me know. I know it was long. Focus on the ones I starred and the ones that are on your study guide, okay? So if you have any questions, let me know. Take care and hit that like and subscribe, and I'll see you all in class. Bye.